This week, we will have a test on solving quadratics. So this is your test review video. I am showing your quadratic formula, your discriminant, which is the part that's under the radical on your quadratic formula, the completing the square formula, which is b divided by 2. Take that answer and then square it. And then I'm also reminding you that the standard form of a quadratic is ax squared plus bx plus c equals 0. So when I'm trying to solve, I am looking for that equals 0. If I'm just factoring, it won't have the equal sign in it. So for this test, we will be solving using different methods. So when we're trying to factor, again, the first thing you want to do is put it in standard form. This is currently not in standard form. It's not set equal to 0. So what I need to do is add 18 on both sides. And so when I rewrite that, that is going to be 3x squared minus 15x plus 18. And now it's set equal to 0. Once I get it to this point, I want to see, is it possible for me to divide out a greatest common factor? And it is. All of these terms can be divided by the number 3. There is not a variable over here, so I cannot take out a variable. When I actually divide by 3, what I'm doing is taking it out front, and then I'm going to set up a set of parentheses. What I do now is just simplify. 3 divided by 3, I'm left with x squared. I bring this sign down and I have negative 15 divided by 3, which is 5, but I also have an x, so I have to bring that down as well. 18 divided by 3 is 6. When I see that I have an x squared still in my set of parentheses, I want to double check to see if I can keep going. In this case, I can keep going. So what I'm going to do is set up a box so that I can use the area model or box method. It's referred to as either. So my first term goes in the first box. So that's going to be x squared. My last term, including the sign, goes in the last box. And that's going to be plus 6. I multiply the numbers only. So there's a 1 understood to be there, and there's a 6. So 1 times 6 is going to give me 6. I'm looking for two factors that will not only multiply to give me 6, but they will add to give me negative 5. So those two factors sometimes confuse people because you automatically want to say 6 and 1. So let's try that. In order to get a negative 5, I would have to have negative 6 plus 1. Well, then I won't have a positive 6. So I know that that's not my answer. What other factors do I have? I also have 3 and 2, right? 3 plus 2 gives me a positive 5. I need a negative 5. So what I have to do is just change the signs. I can have a negative 3 plus a negative 2. And not only will that give me this negative 5 if I add it, but it also gives me 6 if I multiply. So I know those are my factors. I take those two numbers and I place them in my box. Doesn't matter which goes where, but I do have to have my variable. Please don't forget that. This is replacing that entire negative 5x. So for those people who need to just see what's going on, I'm taking that out and I'm replacing it with negative 3x plus negative 2x. Again, that becomes the negative 5x. If I forget my x, I will just end up with negative 5. Sorry. So if I just said negative 3 and negative 2, that's just going to give me the negative 5 part. And that's going to cause me to have problems when I'm factoring. So now when I factor out my greatest common factor, I have an x, I have a minus 2. X times what will give me x squared? X times what will give me negative 3x? So I now have my two factors, and I just have to put them in factor form. But I have a GCF with it. So 3 times x minus 3. Doesn't matter which comes first, the one on top or the one on the side. But it does matter how I write it. So I have to write it from left to right. And I also have to write it from top to bottom. Now I am going to set it equal to 0 because, again, I am solving. Solving means my answer is going to be in the form of x equals something. I told you in class that each factor has to be set equal to 0. Well, we know that 3 is not equal to 0. So we don't even have to include that one. The next one, I also told you to change the sign of what's in front of your constant and divide by what's in front of x. Since there's just a 1 in front of my x, then changing the sign in front of the constant leaves me with a 3. And then on the next one, change the sign in front of the constant. Instead of having a -2, it is a +2. So the answer in this example is going to be x is equal to 3 or x is equal to 2. And I solved by factoring. The next one is asking me to solve by completing the square. So this is where I will need this formula. Completing the square means my leading coefficient has to be 1. If it is not, then I have to factor something out to get it to have a 1 in front of my x squared. So what I'm going to do is I am going to put 2x squared minus 10x on one side of the equation, and I'm going to subtract 3 on the other side, which will get rid of the constant on this side, and I'm left with 15 minus 3, which is 12. I see that I can actually start dividing out each term by 2. Now, if I divide each term by 2, I no longer have to put it out front like I do with my factoring. If I only divided those first 2 by 2, I would have to put it out front. So since I've already divided it, I no longer need that 2. What is left over, though, is going to be the x squared minus 10 divided by 2 is 5, and I have an x. At this point, I told you in class, if there is a 1 here and you have your variables on the same side, just go ahead and put plus blank. Go ahead and continue on, bring your equal sign down, and then 12 divided by 2 is 6. And now I'm going to look over at what's shown here, which is my completing the square formula. I am going to mimic what I see with the exception of the b divided by 2. So what I see is 2 parentheses, well, I'm sorry, a set of parentheses raised to the second power. Now what I'm going to do is take one of these variables and I'm going to place it inside of that parentheses. Then I'm going to take the sign that's shown next to it and bring that down. And now I'm going to follow my formula, which says b. B is -5. Well, I already brought the negative down. So -5 divided by 2. Oh, that's a fraction. It's okay. -5 divided by 2. So what will happen in this case is you will take the numerator and you will square it. And then you will come back and take the denominator and you will square that. So you will end up with a fraction in your blank, but it's okay. So I have 25 over 2 squared, which is 4. Now, what I do to one side, I have to do to the other. So I should have a plus blank here as well. And again, 5 squared is where I got the 25 from. And then the 2 at the bottom squared is where I got the 4 from. So now I want to simplify this side of the equation. Well, I have a whole number in a fraction. I taught you in class, what you can do is just cross multiply that. That's going to be 24 divided by that same denominator, 4. So basically, I'm just rewriting. Instead of 6, it's going to be 24 divided by 4. Isn't 24 divided by 4 6? Yes, it is. So now I just take this sign and I do excuse me, I actually add. So I'm just taking this side and crossing it out and rewriting it. So when I add this, I end up with 25 plus 24, which is 49, all over 4. Because when you're adding fractions, you get the common denominator and then you do not do anything else to it. At this point, you want to take the square root of both sides. Well, let me change that. So that big square root sometimes confuses people. So what you're really doing is taking the square root of the top and the square root of the bottom. But before you can take the square root of either, make sure you put a plus or minus. The purpose of doing that is to get rid of the square so that I can bring down the radicand. X minus 5 over 2 is equal to, well, the square root of 49 is going to be, we already have our plus or minus, 7. And then the square root of 4 is 2. Again, we already have our plus or minus. This side needs to move over to the other side so that x can be by itself. And I taught you in class, if it's already a negative 5/2, then what you're going to do is just change that to a positive and put it right in front of what's already there. Bring all of this down. Now, this confuses people as well. These are real numbers that can be added or subtracted. So in one case, I have 5/2 plus 7/2. And in another case, I have, sorry about that, put that back, 5/2 minus 7/2. So just put that in the calculator if you don't know how to simplify fractions. But for the sake of time, 5/2 plus 7/2 is the same as 12/2, which is the same as 12 divided by 2, 6. So that's one instance. The other instance is where x is equal to 5/2 minus 7/2. And now I have 5 minus 7, which is -2, all divided by 2. I can simplify that. -2 divided by 2 is simply -1. So my answer in this example is x is equal to the set of -1 and 6. That's by completing the square. The next one is part of completing the square, but it's called the square root method. So you did it and you just didn't realize it. So this part is where we're picking up. That's using the square root method. If there is something before or after the parentheses, you have to get rid of that first. So if it's before, you do not distribute. That's a common error. You want to actually divide both sides by what's in front. Now I can bring down my x plus 7 squared, and I can set it equal to 48 divided by 6, which is 8. Now I can use my square root method. Take the square root of this side plus or minus the square root of this side. The purpose is to get rid of that square, bring down my x plus 7, set it equal to plus or minus. Now, with my square root of 8, I can simplify that further using the factors 4 times 2. Well, I noticed that the square root of 4 is actually 2. So this can come out from under the radical, but the square root of 2 cannot. So this is what it looks like. I now have a plus 7 next to my x, but I just want x by itself. So that means I'm going to have to subtract 7. And when I subtract 7, I just bring this down. Excuse that. Sorry about that. So I bring down my plus or minus 2 radical 2. That's my final answer. It's really 2 answers in one. You have a -7 plus 2 radical 2, and you have a -7 minus 2 radical 2. Yes, you can write it apart if that's what you choose to do. Now I want to solve using a quadratic formula. Using a quadratic formula, which I wrote to the side, again, you have to make sure it's in standard form first. What is standard form? Where it's set equal to 0. So let's go ahead and move this -10 over to this side, and it will become a +10. So rewriting that, I have 4x squared minus 5x plus 10 is equal to 0. Now I can identify my A, B, and C because that's what I need inside of my quadratic formula. A is going to be 4, B is -5, and C is +10. So A, B, C. And then I just substituted in according to what the formula tells me. It tells me that -b, which is also a -5, notice that this negative is still here because that's part of my formula. And I'm just going to end up distributing it and changing it to a +5. Plus or minus what I have outside in my parentheses as b will still be here because b is b, right? It's going to be the same number. Keep it in parentheses. -5, but this time I'm squaring it, minus 4 times a, which is 4. And I got that information from over here, times c, which is 10. All of this is going to be 2 divided by 2 times a, which is 4. So if I am simplifying this, x is equal to positive 5 plus or minus the square root of negative 5 squared is simply 25. If you see a negative 25, you are doing something wrong. Then I have negative 4 times 4, which is negative 16. Negative 16 times 10 is negative 160. All divided by 2 times 4, which is 8. I keep on simplifying and I get to, let's write it over here, 5 plus or minus, and now I'm going to see if I can take the square root of 25 minus 160, which actually is going to be, where's my square root button? Sorry about that. It's a negative number. So it's going to be square root of negative 135. And in the calculator, you can do the square root of the positive 135, but you have to remember that there's an I here. So you have to remember that part. But if I'm factoring this out, it's going to be 9 times 15. Yeah. So square root of 9 and square root of 15. Square root of 9 really becomes 3. I can't do anything with square root of 15, so I'm going to have to leave that. And again, all of this is divided by 8. Simplified even further, x is going to equal, and I like to separate mine, 5 over 8 plus or minus, and I'm looking at what I can take from under the radical, which is 3i. I'm left with that square root of 15. I can't simplify that any further, all divided by 8. Can you write it as one big fraction? Yes, you can. I have seen people do that. This is one big fraction. I just prefer it this way because if I can simplify it, I can clearly see it. Okay, number 5, find the discriminant number and type of solution. So this is my discriminant formula taken from my quadratic formula. And what I am doing is I am just going to put it in standard form so that I can identify my A, B, and C. Standard form, 8x squared plus 7x. I have to move this over, which means I'm changing signs, setting it equal to 0. My A, B, and C can be identified now. A is 8, B is 7, and C is negative 3. Substituted in this formula, and it looks like this. 7 squared minus 4 times 8 times negative 3. And my math is 49. And now I have, let's pull up a calculator here. Let me see if I can find it. And again, I have to remember what I'm trying to put in the calculator. Let's see here. Negative 4 times 8 times negative 3. So negative 4 times 8, is it taken? It is not. Negative 4 times 8 times negative 3. I hope that was right. Was it negative 3? Yes. Okay, and that gave me 96. That did not look right. I did something wrong. A. Oh, that is right. All right, so that's going to be a positive 96. And now I'm going to take that and I'm going to add it to the 49 that was there. So that's going to be 145. That's my discriminant. That's this part. So my final answer is not only the discriminant, but the number and types of solutions. So my discriminant, as I just said, is 145, and that will result in 2 real solutions. All right, so the next one is still finding the discriminant. Actually, I have A, B, and C. Finding the discriminant, the number, and the types of solutions. So the first thing that you do is always rewrite it in standard form if it's not already there. In this case, it's already there. So I can identify A, B, and C. A is what's in front of my x squared, which is 3. B is what's in front of x, and C is the number that does not have a variable. Substituted into my discriminant formula, oops, and that will be negative 5 squared minus 4 times 3 times 11. Putting it in the calculator, that's 25 minus 12 times 11. Was that 132, I want to say? Let me just double check. My brain is not what it used to be. -4 times 3 times 11, -132. All right, so we already got the negative there. And now we take that -132 and we add 25 to it. And that gives us an answer of -107. Let me make sure I did my math right here. I have a -525. And that's going to result in, so -107 is my discriminant. And the number and type would be 2 complex solutions, or non-real. You may see that word, or imaginary, you might see. That's going to be my answer here. And now, to distinguish between the two, for me, I've said this in another video, if you ever see a negative, that means you're going to have an I in your answer. So therefore, you're going to have 2 complex solutions. The other one is greater than 0, doesn't have an I, doesn't have a negative sign. I'm sorry, doesn't have a negative sign, it's bigger than 0. So that means it's going to be 2 real solutions. And then your last option will be one like this. So I'm still trying to find a discriminant. It's already in standard form. So identifying A, B, and C, A is going to be 3, B is -6, and C is +3. Putting it in my formula, B squared minus 4 times A times C. And then simplifying, I have 36 minus, and then I have 4 times 12 and 12 times 3, 36. So 36 minus 36 is 0, which is my discriminant. And if that ever happens, then I'm going to have 1 real solution. And again, I said this in another video, 1 starts with an O, but it looks like a 0. So that's how you can remember that one. For number 6, we're going to work backwards. So write an equation when given the roots are -4 and 9. So that means that they're telling me that X is -4. X is +9. So I'm going to work backwards. I have to set it equal to 0, which means I'm going to have to move those numbers over. If I move something over, what do? I change the sign. So X plus 4 is now equal to 0. And then over here, X, I change the sign, -9 is now equal to 0. What do I do with that? I take my X plus 4 and I put it in a set of parentheses. I do the same with my X minus 9. Because again, I'm working backwards. What I'm trying to do is find an equation that's going to result in these zeros or roots or solutions, however you want to call, whatever you want to call it. Okay, so now I'm going to distribute X times X, X times -9. Come back, 4 times X, 4 times -9. When I do that, I end up with X squared minus 9X plus 4X minus 36 equals 0. I can simplify by combining like terms, and my final answer will be X squared minus 5X minus 36 is equal to 0. That is my equation when I am given the roots -4 and 9. I have 2 more word problems. Okay, this first word problem says a pelican grabs the salmon from the lake and flies to an altitude of 256 feet. The salmon manages to wiggle out of its grasp and falls back into the water. Its height, h, and feet can be modeled by h of t equals 256 minus 16t squared, where t is the time in seconds. How many seconds will the fish fall before hitting the water? So this is what you're trying to find. How many seconds? So your answer has to make sense. So let's work with what we are given. We are already given that h of t, which we can actually replace with 0. That's what we're going to do, okay? is 256 minus 16t squared. Why do we replace it with 0? Because we are solving. So I'm going to take, since that t squared is negative, I'm going to move it over to the other side. And I'm also going to move that 256. When I do that, I have to change signs. So I now have 16t squared minus 256 is equal to 0. I am going to use the method of solving by factoring. You can use other methods if that's what you choose to do. I see that it's already in standard form and I have a greatest common factor of 16. So I'm going to take that 16 and I'm going to place it outside of my parentheses. What's left over is t squared minus 256 divided by 16 is 16. Set that equal to 0. And I notice that I have what's called a difference of two squares, meaning there's a minus sign in the middle of two terms. And those two terms, I can actually take the square root of. If I did that, the square root of t squared is simply t. The square root of 16 is plus or minus 4. And if I put it in factored form, I have 16 t. In one case, I have a plus 4. In the other case, I have a minus 4. And I set it equal to 0, which tells me that 16 does not equal 0. So I can get rid of that. And I can change the sign of what's in front of my constant. And that will be this answer. T is equal to negative 4, which doesn't make sense because we're talking about seconds. So I can get rid of that. And then the last one, I changed the sign in front of my constant. So t is equal to 4. My answer is it will take 4 seconds for the fish. How many seconds will the fish fall before hitting the water? So 4 seconds. My last example. Okay. Fizza is building a playroom near the garage. She has enough material for the play area to be 215 square feet. The length should be 38 feet more than the width. What should the dimensions for the playroom be? So we're looking for the dimensions. And this is how you set up the problem. Just realize we are still trying to solve. So we know that it's going to be some type of formula where it's an equal sign in it. So we're going to say her playroom is in the shape of a rectangle. So what we know is that the area is 215 square feet. Area is always measured in square. All right, so square units. I also know that the length should be 38 feet more than the width. Well, what's the width? We don't know. So we're going to just say X. But we do know that the length should be 38 feet more. So the area of a rectangle is area equals length times width. For the sake of substituting this in, I'm going to rewrite that equation and I'm going to do it as width times length is equal to area. Because I'm going to use X as my width times my length, which we don't know as well. We just know that it's 38 feet more than the width. So that's going to be times X plus 38. And we were told in the problem that the square footage is 215. So now we just actually use our distributive method and we end up with X squared plus 38X. And I'm just going to move this 215 to the other side, which requires me to change signs, negative 215, and it's left set equal to 0. That was the whole purpose of moving it. Now I can use my calculator if I wanted to, because I know that I have some big numbers here. So again, not trying to confuse you, but using the area model, if I use my first term, X squared, and my last term, negative 215, I see that A times C is negative 215. Let's go back to my calculator. And on the calculator, I'm going to go to Y equals and type in negative 215. Let me make sure before I guess. And divide that by X. Go down to the next line, do the exact same thing. But this time I have to add an X. And what I'm going to do is go to second table. I'm going to look in my third column. What am I looking for? Positive 38. So where it's red, I'm going to go over and I'm going to look for a positive 38. Follow the numbers. If they're increasing, that's the direction that you're supposed to go. So 38 is shown here in red. And if I look before it, I see my two factors. 43 times -5 will not only give me negative 215, but it will also add to give me 38. So 43 and -5. And it doesn't matter which one goes where. And this was 43. There's a plus sign there. And don't forget your X. So I can take out an X over on this side, and I can take X times X is going to give me that. X times 43 will give me this. All right, and now on the other side, I can take out a 5. What kind of 5? It's going to be a -5 because I'm taking the sign that's closest to me. I apologize, I'm supposed to be somewhere. Okay, so now I am going to put this in factored form, and it's supposed to be X plus 43 times X minus 5, all set equal to 0. Solve for X. X in this case is going to be -43, which of course that wouldn't make sense because you can't have a negative dimension. And then in this case, X is going to be the opposite sign. Instead of -5, it's going to be +5. So to answer my question, what should the dimensions be? Well, we said X represented width. So that's going to be 5. And then my length was X plus the 38. So that ended up being 43. And we already knew that the area was 215 square feet. All right, so these are my dimensions. That is what your test will look like. Hope this was very helpful. Go back, pause, whatever you need to do to make sure that you are prepared for tomorrow's test. Okay, it seems like it's never ending. I'm trying to get back to the top so you can see any of the formulas that you may need to write down. Okay, have an awesome day, you guys.